Good afternoon, and thank you for tuning in for my presentation for Acoustics 2020 on the SSID protocol, a method for practical soundscape assessments in the city. My name is Andrew Mitchell. I'm a doctoral researcher at the UCL Institute for Environmental Design and Engineering, working on the Soundscape Indices research team. So I think so far in this session, we've probably heard quite a lot about Soundscape and using Soundscape for environmental assessments and sort of the theory. So for sake of time, I'm going to skip over a lot of that. And I'd like to begin with just a bit of background of what the SSID project is and what we're trying to achieve. So the primary goal of the SSID project, a bit of a mouthful, is to create an index or set of indices for describing the soundscape of urban environments, which adequately reflects levels of human comfort and preference while integrating measurable and observable quantities. So sort of the main thrust of that is an index which describes soundscapes using objective quantities. And there's a couple of reasons why this is an important current goal of the field. The first is that it allows us to more easily enable soundscape characterization of spaces. With any current survey-based method, it can be pretty difficult to assess the soundscape of a lot of different spaces across the city, which limits the scope of what we can actually apply it to. The second goal is to enable the prediction of the soundscape of a space. So predictive soundscape modeling is necessary for determining the soundscape impact of any proposed design. So in order to determine the likely soundscape of a new space or the impact of a design change in a space, we need a model which can predict soundscape assessments based on objective and predictable factors. So towards this, the Soundscape Index has three main requirements. The first is that it should be based on objective or measurable factors, and particularly factors which can be predicted for a particular space. The second is that it should be generalizable to many different types of spaces. So it's not much use really if we can only use it on a space that we've already assessed. You know, if we've done a massive survey in a space, then why do we need an index in order to characterize it? We've already characterized the soundscape by doing the survey. And then the third is that it should be practical to implement without an excessive time or labor cost. And this gets into that part of being able to apply it to a whole bunch of different spaces so we can really determine the impact of a soundscape on the city. So in order to build this SSID model, here on the team, we needed to build a large multinational database of soundscape assessments in many different spaces. And these assessments needed to be performed in situ and be organized with detailed metadata to enable us to link all of our multiple data streams that we're collecting together. So to do this, we developed the SSID protocol, which is based on repeated questionnaires conducted in multiple urban spaces. And we needed it to be relatively simple and easy to carry out at multiple sites with relatively minimal hassle. So that's what I'm going to be discussing here today. So some of the design goals of this protocol were primarily it needed to gather in situ soundscape assessments from the public, which can be further analyzed and utilized in designing a soundscape index. And the second was to conduct recordings to be able to reproduce the audio and visual environment of a particular location in a laboratory setting to allow us to conduct controlled experiments on soundscape. And so this is particularly allowing us to record essentially what we need to reproduce the environment in a VR situation. And so in order to achieve these two goals, we've split our protocol up into two stages. The first is the recording stage, which is where we gather those audio-visual recordings, and we use 360-degree video, ambisonic spatial audio, and a calibrated sound level meter measurement. And then the second stage is the questionnaire stage, where we use repeated questionnaires combined with continuous environmental data and sound level meter measurements, as well as individual binaural recordings taken while people are filling out their surveys, and 360-degree photos for each group of respondents while they're filling out their surveys. And so all those multiple streams of data feed into our database and into our modeling system. But the protocol that we've developed helps us to keep all of that organized and concurrent and easy to collect. So here we've got just a visual diagram of what a single session of our protocol looks like. So you can see, starting on the left, we've got our recording stage, which involves taking the environmental data, so whatever environmental monitor we're using, the SLM, the ambisonic audio, and the 360 video all run concurrently for about 15 minutes. And then we switch over to the questionnaire stage, where we've got environmental data and sound level meter running all the way through, and then we have repeated questionnaires. And I'll be showing a video very shortly which goes through this entire process. But first, just to discuss what equipment we're using. This is particularly looking at the equipment that we use for the VR recordings. So you can see here our entire setup is all contained within a single tripod, and we've got the 360-degree camera up on the top. We've got our environmental monitor, and then inside the fuzzy cat, we've got the ambisonic microphone and a sound level meter, all self-contained within this one tripod setup. And then the cables run off to each of their pieces of equipment in a backpack. So then for the questionnaire stage, which also makes use of some of that equipment, our questionnaire is based off of the recent ISO standard, specifically based off of method A, which was originally a sound walk, and we've adapted it to do repeated questionnaires. And as I said, this protocol was focused on collecting a large-scale database, so that's why we've split it into these repeated questionnaires. It also enables acoustic and environmental data collection simultaneous with all of the questionnaire collection. And then we've organized it into 3 levels of factors. So we've got the individual level, each person filling out their own survey, as well as recording exactly the sounds that they were exposed to while filling out their survey, and capturing the visual environment with that 360-degree photo to which they were exposed. This then goes into the session level. So our goal is to collect at least 100 questionnaires per location, or maybe more accurately, per soundscape. And to achieve this, we typically have to split it up into multiple sessions on multiple days. And so the goal is to repeat the sessions on days when the environment is consistent, is similar to each other. So usually it takes us about 2 or 3 sessions to get to 100 questionnaires. And then finally, we put all of that up into the location level information. And that's things that don't change across sessions or across individuals. That would be things like the architectural typology of the space, the visual openness of it. The dominant sound sources typically don't change across the locations as long as we're doing it on around the same time of day. And so we just organize all of the data streams that we're collecting into these 3 levels. For the questionnaire itself, as I said, it's based on the ISO standard, and you can see that we've got the 8 perceptual attributes which fit onto the circumplex model of pleasantness against eventfulness. And we then got some sound source dominance questions, which are split up into traffic noise, other noise, human sounds, and natural sounds. And then we have some questions which address the overall impression of the soundscape and the location. In addition, we also in our questionnaire have some questions which address psychological well-being and demographic information. And so now I'm just going to play a little video which demonstrates our protocol in practice. Initially, the researcher walks into the area in which they want to do the survey. The bounds of this area are loosely defined by the area in which the environmental features of the space are consistent, which we've termed the environmental unit. And where the equipment is precisely located for the recording stage is mainly determined by where you want the perspective of the VR recording to be. As you can see, we have all of the equipment mounted on a single tripod with the meters and multi-channel recorder in the backpack, which makes it nice and easy to set up on site. So the cables just go down to the backpack, hooked up to the SLM and to the multi-channel recorder. Then the 360-degree camera is mounted on top of the tripod at approximately eye level, with the environmental meter tracking light levels, temperature, and air quality mounted on the side. It's important to make sure that the front of the camera lines up with the front end fire of the ambisonic microphone. Once all of that is done, the researcher goes down to check all of the settings on each of the pieces of equipment and then starts each of them off recording. Once everything is started, the researcher will then come back up and give a little clap to synchronize the audio and video, and then leave it running for 15 minutes. So once the VR recording is finished, our researchers are prepared to go ahead and start the questionnaire stage. Here they will restart the SLM and pull out the binaural headset and its recorder. Then once a potential group of respondents approaches, one of the researchers will stop them, explain what we're doing, what our questionnaire is, and that all of their data will be anonymous. Once they agree to participate, the researcher hands one of them a tablet with the electronic version of the questionnaire and the other the paper version on a clipboard. The second researcher then stands next to the respondents and takes a binaural recording. Typically, this is done for at least 30 seconds, and it's important for the researcher to keep their head still for the duration of the recording. So we now have a calibrated recording of precisely what the respondents were exposed to while filling out the questionnaire. Once this is finished, the researcher will note down the group ID for that recording, which will be matched up with the group ID assigned to the questionnaires. The researcher then takes a 360-degree photo, and once the respondents have finished filling out the questionnaire, they'll hand everything back to the researcher and be on their merry way. The researchers will then prepare to repeat the process with the next group of people. So you can see that by splitting up our protocol in this way, it allows us to analyze our data set at the individual level. We've got exactly the sound that those people were exposed to, and we can tie that exactly to their responses. And so far, we've extracted 120 psychoacoustic metrics for each binaural recording. And I can later go into more detail of what those metrics consist of if people are interested. But just to give an example of how our multi-level approach is beneficial and having our individual recordings tied to the individual responses is helpful. We can see here what maybe we would typically plot is just all of the responses, the linear LAQ to which these people were exposed with their rated pleasantness, scaled between -1 and 1. And we can see we get something that we kind of expect, right? We've got a negative correlation, so the louder it is, the less pleasant it is. But the question I've got is that consistent across locations, or is this analysis actually just describing the pleasantness of the location itself? You know, quieter places tend to be more pleasant in general. So is it really due to the sound? Well, we can split it out. Because we've got all that metadata, it's actually quite easy for us to just split it out. We can perform separate analyses per location and look at, all right, that relationship doesn't seem to hold across all locations. We can see here that actually most locations do not have a significant relationship. Some of them have zero correlation. And then the ones that are significant relationships, their level of correlation varies from -0.4 to -0.6. So we've got a pretty decent range there of how much the sound level is actually influencing the pleasantness rating. And we've got this difference across locations. Only some locations show this relationship. And by splitting it out the way we have and having individual level information, we can start to look at the particular influence of the sound level on people's pleasantness ratings. But it also allows us to split it up in other ways. For instance, we can split it up by what the dominant sound source was. So which sound source did they say was most dominant in that location? And then we can look at how the sound level relates to their rated pleasantness. And so we can see here that all of the cases, yes, it does have it, and we've got some small differences between them. So traffic has a higher correlation than spaces dominated by natural sound and human sound. And so all of these can help us get a much better understanding of how the sound is actually contributing to people's perception of the pleasantness of the soundscape of a space. So thank you very much for your attention. As I said, this presentation is based off of a paper that we recently published during the lockdown in Applied Sciences, and that goes into much more detail of all of the different parts of the protocol and some of the justifications and challenges that we faced behind it. Thank you very much.